right, so this is the Lulzbot Test 6. First thing I want to mention is we should always keep this thing off, so let's go ahead and turn this on though. Whenever you're not using this, you want it to be off, but I'm going to go over the key components of this 3D printer. Basically, all 3D printers work pretty similar. Can everybody see this too? I don't want to stand in the way of everybody. So the main components are the filament. All the models are created from filament. There's a ton of different filaments, but this is the filament right here that we're mainly going to use. It's about $10 a roll. It's fairly inexpensive, but it's actually pretty durable too. The filament then runs into the extruder. The extruder is an element that heats up and cools down the filament simultaneously and then extrudes it onto the hotbed. These move in conjunction with each other, and you'll later see in the software how that will tie in. The last thing I want to tell you about this printer, and I don't want to overcomplicate this either, so I'm just going over the key basic elements of how this works. Then the last thing you see on the screen, well, the last thing you'll see is the screen. So when your extruder is heating up, the filament needs to be at a certain temperature, and the screen will tell you that. And when that's heating up, it'll tell you its current, one second, sorry. The screen will tell you how hot the filament is. It'll tell you the remaining amount of time that it has to heat up, and then it'll tell you the remaining amount of time that your model has to print. Just some basic info that will also be in the software that will show you too. That's basically it for the 3D printer. There's nothing to overcomplicate about this. It just kind of works. It does everything it needs to on its own. So, and now Cole's going to tell you about our 3D modeling software that we have picked out for everybody to use. It's a beginner software.
So you can't just, if you have a design that you want to print, you can't just look at the printer and be like, all right, that's what I want to do. It doesn't work that way, unfortunately, so you have to use a 3D modeling software. For that, we chose Tinkercad. Tinkercad is it's a web-based program in which you can model designs, but it's cool because it's web-based, you don't actually have to download anything. You can just load up your browser, and there it is. You do have to register, but it's free and it's not really that much of a hassle. And so once you log in, this is kind of what you see. We've already done this before, so some things aren't popping up. But when you first register for Tinkercad, it provides you with a tutorial that you can go through. The tutorial takes around like 5 to 10 minutes, but by doing that, you can learn pretty much all that there is to know about Tinkercad, with like a few minor exceptions. It's really simple software. It's really easy to learn how to do just straight off the bat. So I'm going to kind of show you how this works. I'd say Tinkercad works off of two basic premises. It's additive and subtractive. So the first part is additive. You have these shapes here on the right. So you got a bunch of different pre-built shapes, from like a box to pyramid. You can choose text if you want. I'm going to just choose die shape here. So you click and drag it, and then you can drag it and drop it onto the workspace here. And it's cool because there's different tools, different handles that you can move it up or down, and change the constraints a bit however you want. So this is the first part. This is like the additive section. The second portion of the software here is the subtractive version. So let's just take this sphere, right? When you place an object onto the plane, you'll notice that there's a dialog box that pops up here. You can choose solid or bold. So on the previous one, you'll notice we have solid selected. And we just change this to a easier to see color. With this, we're going to select whole. And what this does is it will cut itself out of any model that it runs into. So let's just take this and run this into this object here. Maybe shorten it down here a little bit. So there we have start. I can't move that.
And basically, so you can take any 3D shape or model and create a hollowed out shape using this, and that's what he's going to do. So he's actually going to hollow out this dice with that sphere in just a second.
Alright, so once you have your design just how you want, you can click these two objects. And then up here there's a group button. Now once you do that, you'll notice that there is now a hole cut out of the object that you created. And this is a subtractive part. So if you'll note, there's a spherical hole because I used the sphere to make a hole in the die object. And you can choose any of these, all of them work. And it's by using this almost like a two-step system in order to build your shapes, there's not a lot of knowledge that's required beforehand. With a lot of your CAD programs like SketchUp or SolidWorks, you need like 3 hours of experience and a PhD in rocket science to begin to scratch the surface, right? So with this, you can just start in 15 minutes and you're already making your own designs. So once you've created your design that you like, obviously I'd spend more time on this, but you can go up here to the options. Now, there's an import option, so if you found the design on the internet or you had a different design from a different program, you could put that in here and start working on it in Tinkercad. But let's say that you're done with this program, this object, and you want to give it out to be ready for 3D printing. So you go up here to this option up here, the export option. We recommend using OBJ because that's the most commonly used 3D format, 3D file format. So you click here, and then once you do that, it's really simple. It just puts your object into a zip file, which you can then download, and then extract to wherever you desire. And then here you have your OBJ file that you can then use into your slicing software in order to 3D print. You can't just print. You can't just print it. You have to, once you have your 3D model, you have to do some things to it just so that it's ready to print. And that's where the slicing software comes in.
Okay, and so all 3D printers use slicing/printing software. And basically what slicing means is you have your 3D model as he just created. Slicing is basically slicing is the code that the software does to make the printer understand the 3D model you just imported. It converts it into layers. And so later on when we start the printing process, you'll see that it'll go diagonal, it'll go horizontal. It's the way that it prints it. It has to be able to print that 3D model, and that's what slicing does. It converts it into a ton of different layers, and that's why it's called slicing software. So now I'm actually going to go into the software itself. This is Cura. Cura is actually an open source 3D slicing printing program. Lulzbot, the creator of this printer, has made their own version. It's more compatible with this printer, and it's fully functioning. The first thing I want to mention is in your 3D space here, this hotbed, and this is what this is called, this part right here, that hotbed is a 1-for-1 representation of this. So everything you put on there is where you can expect it to end up on here. And so now I'm going to import the 3D model he created. Let's see. Okay. And we should notice one side is hollow. There it is. Obviously, this is kind of small right now, and so now I'm going to go over 4 main settings in this program that you're going to want to be using. First you have to select the object. The first tool you're going to be using is the Move tool. The Move tool is pretty self-explanatory. It allows you to move it along the plane, along the Z or the Y axis, or the X or the Y axis. The only time you would ever use the Z axis, moving it up or down, because obviously, first of all, it won't let you. It's always going to drop back down. You can't print something in midair. This printer's not that advanced. So, the only time you would ever use this is you can obviously import multiple 3D models into here. If you wanted to set that on top of another 3D model to print it, that's when you would use that. So that's the Move tool. It's pretty self-explanatory. The next tool is the Scale tool. This is probably the most important one. This might be a bit small for some people, so if you wanted to increase the size of the object, right now we have uniform scaling selected, so it's going to be proportionate. Usually you want to keep the proportions unless you wanted to change it for whatever reason. So the way you do that is you simply drag any one of these, and fortunately Cura will readjust. So again, you can't print in thin air, so it'll always make sure the base of whatever object you're printing is on the base of the hotbed itself. And so you can use this slider, and if you want to be more refined, we found out this the other day, it's actually a lot more simple. You can click in any one of these boxes and use the up and down arrows and get kind of a more slow, refined way of scaling up or down. And also, this doesn't always work perfect, but if you want to fill up the whole entire hotbed, there's a scale to max button. This will fill up the whole entire plane, and obviously that's kind of huge and it's a little too big. And so it does this every time too, and at least it tells you it won't be able to print. It says unable to slice, and so what you want to do is you want to adjust it just a tiny bit. So let's go back to our scale tool. Shrink it down. It'll turn green when it's able to, and you could print something that big if you wanted to. That'd be a huge die. That is probably the definition of a weighted die. So let's see here. Then the next tool is the rotation. Actually, let's undo that. We don't need to keep it that big. The next tool is the rotation tool. Normally, I don't feel like you're going to be using this tool too much because, again, you always want to print with a flat surface on a flat surface. And so, for example, if we rotate, if I can get it to work here. Let's see. Yeah, as you can see, it rotates. There would be issues with that because you no longer have a flat surface. The program would have to generate supports for this die now. And those are really hard to break off, as me and Cole have experienced. When you have an object at an angle, it basically has to account for that because otherwise it wouldn't be able to print. All the material would just fall, and so it would lean.
There's this thing called gravity.
Yeah. And so fortunately, this is going to happen. We're going to import another, or I'm going to import another model in just a second. But let's use this as an example. If you import your model and for whatever reason it's skewed like this, the easiest option this has, so you can manually try to flatten that to there, of course, or you could simply just push the lay flat button. And all that does is it takes, well, no. This is the first time we have not had that work.
It's a loaded die.
Well, in this case, you would have to do it manually. Basically, you would want a flat side of this on there. We'll keep this for now because we're not going to actually end up printing this model. But there's one more model, or one more option I'd like to show you guys before I import the other model. And that's the multiply object. If you were printing dice, obviously you wouldn't want to print one at a time. The thing with 3D printing is it's kind of a slow process. It can take anywhere from 20 minutes to hours. And so if you wanted to do multiple dice at once, all you would do is click the multiply object button, and then if you wanted 5 dice to get printed at once, it'll do its thing, it'll duplicate those. Now you can print multiple ones at once. Obviously they would be aligned a lot better, but.
And then this is useful because every time that the 3D printer goes through a print process, it has to heat up the bed, heat up the extruder, and then print out the model that you're making. And then once it's done, it has to cool off the extruder and then cool off the bed. So that process can take anywhere from like 5 to 20 minutes, just depending on like what type of material and stuff you're using. So if you're printing a bunch of things, you're going to print in a row, you might as well just do it because you'll save a lot of time that way.
But we're not actually going to print that. As a dedication to TechStart, we actually have a TechStart logo here that we 3D extruded from the actual logo on the website itself in Photoshop. And this is actually a perfect example because if you noticed, it's kind of floating in the air right there. And I'm hoping the lay flat tool actually works this time. If we lay flat, there it goes. It lays it perfectly flat. And so one thing you might notice about this model is if it were to print this right now, none of these are attached to each other. And so that's where this screen comes into play because I've gone over all these tools. You have your move. You can basically move on every axis. You can scale, you can simply move it, you can rotate it, and you can duplicate it. Those are the key principles of the software. Now we're going to go over here because we're not ready to print yet. There's still a few more settings we want to change. So the first one, which I feel most people aren't going to have to mess with this because our filament's already in place, so I think we're going to stick with this filament we're using for a while. But if we ever happen to get another material, you would simply look at the front of it, find out the name of the material, and then select it accordingly. The reason why there's different material settings is these are made of different compounds. Different compounds have to heat up differently, and so the software will change those settings accordingly. Right now we're using Polylite PLA, and it's already set, so that's fine. We don't have to change anything there. The second thing I want to talk about is the profiles. And these can get more in depth, but I would recommend just sticking with these. The high detail is it's going to take the longest, but it's going to look the best. And so this is where you decide whether if you want to wait hours or if you want it to print in a matter of minutes. The high detail is going to take the longest, but it's going to look the best. The standard will balance those. It'll take kind of long, but it'll still look pretty decent. And then high speed is it's going to go as fast as it can, and you're going to have mixed results. It might not look so good. Some still turn out really well. It just depends on what the model is. And then the next setting, this is probably one of the most important settings, is the infill setting. Obviously, we have a limited amount of filament anytime we print something. The infill setting is basically how the software tries to conserve filament. So if you're printing a big model, you can turn your infill lower because it can cut corners. What may appear solid on the outside can actually be hollow on the inside because it's saving filament. When you print a small model like this, we're actually going to turn our infill all the way up because smaller models don't have room to cut corners. They need to be full quality. There's nowhere to make that hollow. It's already small. Also, another thing to mention about infill is a smaller infill will print faster because, again, it's cutting corners. So if you're on a time constraint or it's not necessary, smaller infill will print faster. 100% infill will obviously take longer because it's filling in every single crevice it can. And then the last option to go over on this screen is the build plate adhesion. This is where actually this is a good example because the TechStart logo, let's start with the skirt. The skirt is basically an outline of this whole model. And you can see the gray shadow under there. That's the area of that model itself. The skirt's simply just going to make an outline for the sake of the print head knowing where to stay inside. The print head obviously doesn't want to print outside of what it needs to print. And so it'll just make an outline, it'll stay within that area. The brim will go a little farther. The brim is a skirt that's actually attached to the 3D model itself. And so it'll be just on the very edges. That's if you want them together, but it's still not as solid as the last one, which is raft. Raft will actually make a backing, an actual back. It'll use the filament, it'll create that, and then it'll set the model on top of it itself.
And there's a model going around to show you what that raft looks like when it actually 3D prints.
Yep.
This is the raft, so we'll be sending
Yeah.
it around, that is the logo with background, so they can bring it.
Yep. All right, and then there's one final thing, not an option, but it's for everyone to know, one, how long it'll take, and two, how much filament you can expect to use. So that's always down here, and the more settings you change up here, the more this will reflect. It changes every time you even make a small setting. So for example, this would take 2 hours and 36 minutes to print at 100% infill, but if we were to lower this to 30%, give it a second, it'll say slicing, and it does it fairly fast. 2 hours, 20, well, that doesn't lower it that much. That's because this is fairly big. We're gonna shrink it down, and we're actually gonna show you guys in real time how it prints. So let's go ahead and shrink this down.
And then infill only affects if a model can be hollow. So if it's something like this where it's pretty much just an outline, there's not a lot of space there for it to be hollow, so it doesn't actually affect the time that much.
Yeah. So let's go ahead and shrink this down. Let's say we want it to take about 20 minutes, which is what we're going for. That's going to take about 39 minutes. We can shrink it down even more, but again, we want 100% infill on this because there's no room to cut corners in this model. So we'll shrink it down here. 22 minutes, that's fine. And so we're actually ready to print now, unless there's anything else, Cole. That's everything on as far as this, right?
Yeah.
All right, there's two main screens. There's the prepare screen, which is the one we've been on this whole time. And this is where all your options for moving the model are. When you're finally ready to print, we're going to go to the monitor screen. And the monitor screen is going to tell you all the information when we start the print. There's actually nothing you have to change here. This is just information for you when we start the print. So I'm actually going to click Start Print. Let's make sure the printer's connected first.
And what was selected? You said?
The what?
You said make sure something was selected.
Which to make
The-
sure that the printer is being seen by the software.
Yeah.
Oh, okay.
And now it's starting to move. Sometimes it takes a second. And then as you can see on this screen, this is just information. The filament, the hot head, or the extruder, it has a ton of different names. This has to heat up to a certain temperature, and then it's going to do that in the background. It's also going to move and calibrate on each one of these edges so it doesn't go beyond the edges of the hot plate. And from that point, you just let it do its thing. It's all automated after this point. And so the last category we want to go over is just kind of general cleaning and maintenance. To clean the hotbed, we should clean it off every single time afterwards because a buildup of filament will happen. You just want isopropyl alcohol and a small rag or some Q-tips just to clean that filament off. And then also, when your model is finished printing, all you need is a little pry knife that's going to be in that tool bag. That's the main tool that we're going to use. None of the other tools really need to be used. And so, yeah.
And then
Is there anything else?
Talking about at the beginning of the presentation, these numbers right here, like the status of the printer, is also on that display on the printer itself.
Mm-hmm. And one more thing I'd like to mention is no one's going to have to download this software on their computer. We're going to have the 3D printer positioned over there right next to that HP printer. It's going to be hooked up over there. It's going to still be on here. And on the computer, this software is going to be on there. So the idea and the workflow of the way we want this to work is everyone can design their 3D models in Tinkercad online. You go to Tinkercad, and then you download the model, you hook it up to a flash drive. We go over to that computer over there. The software is already on the computer. You just hook your flash drive up, import it into the software, and then you're able to print it. And so this is going to take 20 minutes, and so we can take questions. I don't know if there's any questions. So. Yeah.
I have a question, Josh.
Yes.
So, when you were looking at reordering filament,
Uh-huh.
there were like 17 or 20 different kinds of filament. I think we went with the lowest quality just to have something to play with in there. But did you guys learn anything about the different, why are there so many different types of filament?
There's different filaments for different durabilities. If you are, for example, trying to design something that has moving parts, or it's going to have a lot of pressure on you're going to want something that's durable. Okay, so this filament, even as cheap as it is, I feel like this would hold up to anything you could create on it. This filament's actually extremely strong as it is. The more expensive filaments are even stronger. And I'd like to mention that when you use those, the adhesion becomes extremely strong until you would need a glue stick. And the reason you would put a glue stick on here is because prying it off becomes impossible, actually. Me and Cole had tried to pry off the previous filament we had with a pair of pliers. That's how stuck it was, and we actually broke it in half because that's how much force we had to put. So the stuff is strong, but basically this filament won't stick. But let me get back to your question. Basically, it just depends on what you're designing. For most practical applications, this filament will be fine.
Well, you
Yeah.
mentioned different colors, especially if
Uh-huh.
this is a one head, one extruder,
Yeah, single head extruder.
and some have more.
Yeah. Cole actually had found something interesting. Do you want to?
So yeah, so what a dual head extruder does is it basically has two rows of filaments and it simultaneously prints with both. One, apart from just color changes, which is kind of like the obvious choice, what you could also do is choose one filament of a stronger, more durable type, and then one filament that's a lot less durable, it's more susceptible to wear and tear. And you can use the second, not as strong filament as supports. So if you want to create a model, like let's say you want to create a model like this, right? I don't know if you can all see, but it's kind of a character fighting. This character is fighting. This character that's fighting, they have arms and stuff that have to be supported. And to support something, you put extra filaments that just connects from whatever's floating to the ground.
It's called, if I can interrupt real quick, it's called overhang support. Basically, if you're printing something that has something that's going to droop naturally, if you're trying to print it, it has to create a support for it. Okay, anyway, continue on. Cool, sorry.
And so with that, once the model's done, if you only have one filament, one material that you're using, all that really, you just have to separate, oh, this is the solid model, and then this is what it's actually, what you have to remove. And so usually that just involves like pliers and a lot of patience also. Don't injure yourself in the process. But if you have two filaments and one of them's a lot weaker and not as strong, the weak one, it's not strong, it's not meant to be strong. So you can use that kind of as like a cutaway. And so like for instance, you can just put the model in a chemical bath, which will dissolve the weak material. But since the strong material isn't affected by those chemicals, it's a lot easier to print out those models that have a lot of overhangs and therefore require a lot of support.
Are there any more questions?
I've got just a
Okay.
refresher. So you build the model in the other program, the online program.
Yeah.
And then you import it into here. And that's this is what the printer recognizes.
Yeah. And there's options in Tinkercad to print, but we wouldn't recommend that, mainly for compatibility issues with this printer. It's best to use the software that came with it, and so.
And then you don't get as many customizable options. Like with this, you can choose everything, and with that, it's just generic. The printer just accepts it. It doesn't have a chance to edit it and make sure it works, and you might get like, issues with your print.
Yeah. Yes.
So essentially, you're saying that you can use Tinkercad as your own wherever at home.
On any computer, yep.
Yeah.
Since it's web-based.
And then you download that
Once.
to a flash drive.
Yes.
You bring your flash drive in, and then you import it to Cura.
Yes. Yeah, because we'll have a station over there, and then so once it's designed online, you're able to download the file. You want to copy that to a flash drive. You want to go to the computer, and then you want to import it into the software. So that's going to be the workflow for that as of right now. So.
And I believe adding on to that, there is a cloud-based storage for your specific account that you have. So you can just log into that computer and then log into Tinkercad with the website on that computer and just skip the USB middleman.
Yeah. Yes.
Two questions. I know we got a donated used computer to drive this. Does the speed of the computer impact the performance of the printer, or is it?
No. The only thing that would be affected, and it runs fine on that computer, but the only thing that would be affected is how well the software runs. Once it's done and set, once it's printing, that doesn't affect how the printer is going to turn out when it's printing. So.
And second question.
Yeah.
Did you guys play with any of the sites where you can download pre-done models that you can modify and all that?
We've done that too. There are some free model websites. I'm trying to think of some off the top of my head.
Thingiverse is one of them.
Thingiverse. There's TurboSquid, and you have to make an account. They have free models though. This is basically if you want to download a model, you find something interesting. You either want to recreate it to learn how they made it, or if you just want to modify something and kind of repurpose it for your own use. Can you think of any other sites? Cool. If you type in free 3D models, there's a ton of websites that come up on Google, and so
you
it's
can download the Starship Enterprise and
Yeah.
modify it. Somebody's already done all that work, and you can either pay for it or get it free and
Yep.
modify it, and it'll work.
Yeah. Let's, one thing I want to mention though is, as Cole said earlier, there's a specific file format that you want to use. It's .obj, that's the extension. It's an open file format. It's the most common one, and we recommend using that. So on these websites, it'll tell you when you go to download a 3D model what type it is. There's a ton of them. You want to make sure it's OBJ because it's going to give you the most compatibility. You can import that into TurboSquid, or even if you want to download a 3D model and import it straight into Cura to print it right away, that's also why you're going to want that file format. So.
And it doesn't have to be OBJ, but that just eliminates most, if not all, of the problems that you'll ever encounter.
Yeah, Cura only supports 3 of them, and OBJ we've had the best success with. So, are there any other questions?
Any problems that you've encountered while trying to make models that you can school us on so we don't make the same issue, make the same problem?
Yeah, well, that model that we passed around, actually, some of you may have noticed that actually got glued together. Some of it broke off, and the reason for that is models with overhangs are actually really difficult to print. There are more settings that we're still going through even to make sure that it's a balance.
And so,
So.
like, with that model, we have to print supports, and because the settings weren't just right on the supports of that model, it printed supports through the model, and because supports are meant to be removed after, they aren't not as strong as the model itself, and so that support material overwrote the actual model itself, leading to it being a slicer, as it were.
Yeah. And so I think I can demonstrate that real quick, actually. So if we increase the size of this, let me go to the scale tool.
So this obviously doesn't affect the current print job.
Yeah, you can still move around within here.
Can you cancel all print out if you
Yeah, you can pause and cancel. Pausing, I don't really know why so much you would do. You usually just want to let this run, especially with how long this thing takes. Just kind of want to run in the background, check on it every once in a while to make sure no errors are happening. You can abort it, obviously, if something starts going awry, which we've had, to answer your question again, yeah, we've had a few things go awry where some things are so intricate, the filament can't keep up, and we still have some experimenting to do with that too to see how we could solve that issue. There are issues that are going to come into play when 3D modeling, mainly for the super, super intricate 3D models. Like if you're trying to print a person that has a lot of detail, it's all based on the amount of polygons that a model has. So, but if I can rotate this, obviously this 3D model doesn't have much overhang, but I'm going to try to make it so where it does. So this is technically considered overhang, obviously, because it's floating in air. And so what the printer would do, if it was doing it right, is it would create just, I can't think of the term. So basically like, not logs, poles. Basically, it would make a pole out of filament and put it under the crucial parts that would need to stand up. And so there's a generate support button here. And again, I wouldn't recommend using the setting just yet. Maybe we will retouch on this later on when we get it more down. But actually, that's under the custom settings. We don't even recommend going into the custom settings yet because I will actually briefly touch on this. Every single thing this printer does can be customized. And that's going to be a lot for everyone. We didn't want to get into that because we just want you to be able to print make a model or download a model, get it in here and just print, because this is how intricate this printer is, though. It's a $2,500 printer, and so. But I just figured I'd touch on that real quick. Basically, the way support works is if you have anything with overhang, it's just going to create poles for it to hold up, and it's not perfect every time, and we still need to work on that. So. Yeah. To try to make that as simple as possible.
The last thing I wanted to ask was about scaling. Does it matter? I mean, you can go as big as you want, but how small can you go and it still come out right, I guess, for lack of better words?
Well, that's based on the actual diameter of the print head itself. It can only
Our print head has a 3 millimeter diameter.
If we go to high detail, did I just mess that up? When you change that might mess it up actually. I just realized this thing hasn't been printing the whole time either, so. We'll figure that out in a second, but if I can move over here actually real quick. Yeah, so as you can notice, this is 0.18 millimeters, and so that is the maximum diameter of the print head. And so if you were to go any smaller than, say, that, you would start running into issues because that's as small as it can get. So, which is pretty small, but this 0.18 millimeters, which is still pretty small. So, yeah. So when it comes to, I guess basically the best way to answer that question is, when it comes to that, make sure your infill is set to 100 because, again, no cutting corners. And it should handle it, but it depends on how detailed the model is.
I wanted to point out, kind of going back to that support thing, if you turn the model over, you'll see these red spots. And that's the computer letting you know, hey, this is where the support needs to go.
Yeah. Which actually, this is accurate. Sometimes it's not so accurate.
Yeah.
Right now, all that red, it nailed it because this is a pretty simple model. It's all red because it can't print like that, so it would just fall down. And so it would create a pull under each like crucial part where it needs to be. And it's not always like that. It just depends on the model. It also depends if the model is created by a certain person who let's say didn't create it properly, like it looks right, it looks fine, but if there were hollow parts in the model, or if there's different joints that weren't properly added right, then it'll try to support parts that aren't. Yeah, so it depends on the person who made the model. If you're downloading a pre-made model, obviously, if you made it and it's a pretty simple model, it should be fine. But it's a really finicky thing.
And that's another thing why we recommend not trying to build a model with supports until we get better with that, just because the amount of problems that can go wrong are immeasurable.
Yeah. So when we printed, where's that figurine at? If I can just see that real quick. Thank you, Jason. So when we printed this, I wish we would have taken a before picture, but basically this was completely encapsulated in support. Like you couldn't even tell. Like, okay, what's the in Star Wars when Han Solo is in the carbonite? Yeah. If any of you, that's what this was. And so we took the pair of pliers that were in that bag and we pried all of it off and finally got to the center of it. That's an example of over support, and there could also obviously be under support, which would mean none of these arms would have actually turned out the way they did. This turned out better than it could have, but it was still pretty bad right when we made it. So, and then this is the first time I had started this. This was going to be a 7-hour print. I came in 2 hours later because I just had a feeling. I wasn't sure. This was the first time trying to print a figurine. I came in 2 hours later. The legs were completely fine, and the rest was just a bundled like jumble filament. It was like, it was pretty bad, and so that's why printing things like that are pretty finicky. So we still have more work to learn. We have more to learn on that.
So for a model like that, would it have been better to rotate it so you're printing it on its back?
On its back, yes, and I tried that, and you still encounter issues. That's the thing. Yeah. So if you run into issues trying to print upward, that is the first good idea, is to try to print it on its back, but then you deal with other issues too. So. For example, that model has hair, and so if it's on its back, it's not going to get the hair correctly. And there were still parts where it would have needed support, and so with just that model, it didn't really matter what angle you turned it, it still ran into issues. So it's all based on, it's a per model basis.
Right, so we want to thank you guys for doing this. This is awesome. Thank you.
Thank you.